Alright, so actually we are done for the subtopic 1.1. But here, I just want to give you a few examples for the calculation involved. Okay, so the first example, okay, they give you the mass spectrum of magnesium. Okay, this is the first example. They give the mass spectrum of magnesium. If you can see from the mass spectrum, okay, how many isotopes for magnesium? Okay, how many isotopes? Okay, they have 3 isotopes because they have 3 peaks. Am I right? Okay, so if they ask you how many isotopes magnesium have, so the answer is 3. Okay, how you want to write down that? Okay, we have magnesium 24, magnesium 20, 25, and magnesium 26. Okay, so if you want to make things easier, I like to put, okay, to interpret the mass spectrum in terms of table, something like this lah. Okay, so from this table, it's easy for you to see, okay, what is the mass and abundance for each masses. So for example here, magnesium 24, the abundance is 63. So 24, 63. 25, 8.1. 26, 9.1. Okay, ni untuk awak tak salah kira lah. Okay, so for example, in this question, they ask you calculate the average atomic mass. So, bila mana dia minta awak calculate average atomic mass, okay, the first thing you should come across is the formula that you're going to use. Okay, formula for average is sum of QI/MI over sum of QI. Okay, so what is Q, what is M? Q is abundant. Q is abundant, M is mass. So, sum of each one of this. So, for example, 63 times 24 plus 8.1 times 25 plus 9.1 times 26. That is meanwhile sum of Kimi ni. Okay, sum of Ki pula adalah sum of all abundant. So, sum of all this. Okay, so something around here. Okay, when you do the calculation, you're going to get this value. You should try this, okay? Okay, and don't forget to put the unit U, or you can put AMU as a unit. Okay, so when you can get marks, okay, the first mark is you put the formula. The second mark, you put the value correct. And the last mark, okay, you get the answer with unit correctly. Okay, so this is the simple example for mass spectrum. Alright, now we go for the second one. The second question. Okay, they also give you the mass spectrum. Okay, but the mass spectrum here, the abundant, they change to intensity. Can you see that? Okay, but it's the same thing. Okay, so from the mass spectrum, okay, how many isotopes that chlorine have? Okay, they got 2, right? Because they have 2 peaks of mass spectrum. Okay, the first question, they ask you, write the notation for Cl isotope. Notation means the isotopic notation. So, isotopic notation, if you can still remember, you should have symbol. And then, you should have nucleon number. And down here, you should have proton number. Okay, so here, we are talking about chlorine. So, you need to put the Cl symbol. The symbol for chlorine correctly. Okay, and for A, nucleon number refer to isotopic mass. You should remember, okay, nucleon number is equal to mass number of atom. Okay, and if you can see, okay, instead of they put M over E, they also can say isotopic mass. These two is different, the same thing lah. Alright, okay, so for example untuk chlorine 35 and 37, if you can see, and down here they put the proton number. But the proton number is not given in the question. But you should not to worry sebab, okay, the proton number you can get from the formula booklet. Okay, in the exam, they will give you the formula booklet. Inside the formula booklet, we have list of proton number of element. So, cari dari situ lah. Okay, boleh. Alright, next. Next, they ask you the percentage abundant. Now, they give you the abundant in term of intensity. But they ask you to change the abundant from intensity into percentage. So, kalau dia minta buat macam mana? You get the ratio lah. Okay, so kalau nak dapatkan berapa abundant percentage untuk 35. So, 35 abundant dia 3. Okay, over total abundant berapa? 3 plus 1, 4. Okay, sebab dia minta percentage, you need to times with 100. Okay, ni jalan kira dia. So, ini untuk cari berapa percentage abundant untuk chlorine 35. Okay, awak akan repeat the same thing untuk chlorine 37. Okay, dapat Okay, the next question. They ask you, which isotope of chlorine is more abundant? Maksudnya apa? Yang ada highest intensity, yang ada highest ratio, yang ada highest percentage. Yang ada highest percentage mestinya yang paling tinggi peak dia. So, which one? Obviously, chlorine 35. Okay, next. The question asks you to calculate average atomic mass. Okay, so the same thing. If they ask you to calculate the average atomic mass, first step you should put formula. Average atomic mass equal to sum of Ki over sum of Ki. You got 1 mark. And then you put the value. Remember, Q is abundant, M is isotopic mass. Sum of that 35 times 3 plus 37 times 1 over sum of abundant 4. Okay, you can use abundant in terms of intensity, okay, or you can also use this value as your abundant. It's the same thing. You're going to get the same value. Okay, and don't forget average, they're going to have unit U. Okay, you should try to do the calculation for this. Okay, and the last one, they ask you to calculate the relative atomic mass of chlorine, right? Okay, so for relative atomic mass of chlorine, you should remember the formula again. Relative atomic mass, or AR, is equal to average over 1 over 12 times mass of carbon 12. Okay, so the value is 35.5. Is from here, you put it inside this. Okay, over 1 over 12 times 12U. So we just cancel out U. Therefore, they got the same value but no unit here. Okay, next we go for the next example. Alright, okay, next they give you, okay, 2 isotope for lithium. Okay, and if you can see here, the atomic mass of lithium 6 and lithium 7. Okay, actually 6 and 7 is atomic mass, but sometimes they will give you the mass in detail. For example, lithium 6, the actual mass is 6.0151. Lithium 7, the mass is 7.0160. So, for the calculation, you should use this mass given. Okay, not 6 or 7 only. Alright, so now, they ask you, what is relative abundant for each isotope? Okay, if relative atomic mass is 6.941. Okay, so this is relative atomic mass, the AR. And the AR value is the same thing with average atomic mass. Am I right? Okay, so average atomic mass of lithium also 6.941, but it have unit U. Okay, now we have the average. Okay, and they give you the MI, the mass of isotope. But the question asks you, what is Q for each isotope? Can you get it? Okay, so because we have 2 different isotope for lithium, okay, we need to put an unknown. Okay, so the first unknown we identify as X. So the abundant of the first isotope is X, and the abundant for the second isotope is 1 minus X. It's something like this, sayang. If you have a piece of cake, if the first, is the first part, okay, this is X. Okay, what is the balance? Okay, the balance is 1 minus X. Okay, 1 minus X, something like that. Okay, you can also use as percentage. Relative abundant lithium 6 is X. Lithium 7, 100 minus X is also accepted. Okay, so by using the average atomic mass formula, okay, we just put all the value inside it and get the X value. Okay, so when you get the X value, okay, you can get the abundant for each one of these isotope. Alright, boleh Okay, when you come across, if they ask you to calculate the abundant, okay, for different isotope, you need to make sure that you put unknown, which is X. Okay, the last example. Okay, this is the last example. Okay, so they give you the element Z. Okay, and element Z has two isotope, which has mass 79 and 80. Okay, and they give you the relative atomic mass. They give you the AR. Okay, and it's the same question. They ask you to determine the percentage abundant. Okay, so the previous question is the same with this example number 4, but in this question, they ask you to calculate the relative abundant. Okay, therefore, we can use, for the unknown, x and 1 minus x. Nampak tak? Okay, but if they ask you to calculate the percentage abundant, for the unknown, you can straight away use x and 100 minus x. Okay, but the calculation method is the same thing. Okay, you get the relative, so you can get the average atomic mass value. You have mass for each isotope. Okay, and you just put the x into the formula. Okay, you should try this. Alright.